if you can hear me just fine. I certainly know you can see my screen because I'm also logged on to my mobile device. Thanks for the thumbs up. Really appreciate the feedback. So on with it. I wanted to start off with two apologies. My voice is still a bit hoarse here. So there's that. I'll try as much as possible to ensure that my voice is slightly elevated so that you can hear me. But it's still going to be a bit muffled here, obviously, right? I don't know what I caught here at the event I was attending. And then also, apologies for yesterday. It turns out that the personal engagement I had in Kabwe ended up dragging. So we were only leaving Kabwe around, that was around 16, towards 17 hours. So, I knew I wasn't going to make it back in Lusaka in time for us to have a class. In fact, I was only arriving around 20 or something. But anyways, we're going to continue nonetheless. We'll try and see if we can find a slot for the missing class. A reminder that these well, this is a slot for the missing class, but these are makeups, right? And I'm not, no pun intended, but I'm not making things up here. These are makeup sessions because if you remember, we started interacting in this course late, right? Late. But I realized, you guys, I realized that when we're having our Q&A session, I guess turned into a Q&A session, which, by the way, is supposed to have like a corresponding makeup session, right? We're supposed to have been covering stuff we're going to cover today here. So we will find time, don't worry. But I realized that I didn't really explain, I didn't explain what my email on the 1st of August was all about. I sent out, I think I thought about 2 emails, right? Giving you a heads up to say we're going to have in-class quizzes. All right. So the very first one is going to be on the 14th of August, I said in the email. And the idea behind the in-class quizzes is precisely that, right? These are going to act as our substitutes for labs, right? If you remember, I don't know how much of this you remember, but I'm going to remind you nonetheless. If you go to the program, to the syllabus, really, we're going to call this the syllabus, you'll notice that assessments have, excuse me, a 10% allocation, right, towards labs. And so what I'm doing is every time we cover a major topic, if you will, I mean, I share notebooks, obviously. So my assumption here is that you understand the stuff we've covered, right? But also, in addition, what I've been doing, at least as it relates to the most recent lecture series that we finalized, that we wrapped up, is I've been sharing tutorials, right? So I shared a notebook that comprises of problem sets linked to this notion of tutorials and labs, if you will. So brace yourselves. We will have an in-class. It's not an open book assessment, closed book assessment. You'll be there, right? Writing. And the quizzes, really, the format I like for quizzes is there won't be any more than 15 minutes. So, we'll spend the first 10 to 15 minutes administering the quiz. You probably want to make sure you show up on time. And then afterwards, we continue with the remaining half of the, I guess half, I don't know if it's half or slightly more here, of the lecture, right, to cover the topic that we'll be covering, right? So brace yourself. This is like on the 14th of August. So there's still a bit of time here. So it's after next week, right? Sorry, it's next week rather now, because today is Monday. And then I said that on the 21st of August, we're going to have another quiz, an in-class quiz, right there in SLH. And it's going to be based on the lecture series that we're covering right now, right? So that's 3 weeks from now, so brace yourself. And then I think, so when I was putting together the document that I'm going to be using to compile scores, if I can just find it. No, it's hidden somewhere in the mess of stuff I'll be looking at here. Document that has I don't know what it is here, but there's a document that I'm putting together that I'm going to be using as a staging. It's like a staging area before we move the the compiled marks to the Moodle ideally. So what you will notice is that that thing has there we go, it's here. This is what I wanted also. So this thing will have, it has a whole bunch of different categories, right, linked to the assessment. So class participation, things like project selection, what else is there? The report and all those things, and there we go. These are the labs here. So what you'll notice when I share this, once I'm done compiling this, the preliminary kind of assessments, because it's going to be dynamic, what you'll notice is that currently it has like 2 quizzes, but I'll slot in another one because I think there's still a bit of time here. So if we have a quiz on the 14th and on the 21st, we won't have it on the 28th because I'm attending the ICICT conference, but we'll certainly have it on the 4th. Now, will be the last one here, right? Because immediately after the 4th, the following week, we have a test. So I have our test scheduled for the week of the 8th, which is really the last week of classes. So I'm just, this is me giving you a heads up of some of the things that are coming your way. And of course, I've been formally communicating with you via email, as indicated in the very first Administrivia lecture series, where we highlighted the fact that communication is going to be done via email or something. Something else I want to mention here is that if you look at, I'll kindly ask to mute for you to mute the microphone. I can't see who that is. I think it's, I don't know if it's Alec or something like that. But yeah, I don't know what that is here. But if we can, it's always the peers here, right? The peers are the ones that are cheating, fabricating attendance. They're the ones that are making noise. I have no association with these peers that are messing up, right? But something else that I have done is what you want to do immediate after class is you want to take time and look at you want to look at you want to look at the project specification document, because what I've done for the project is I've kind of like fragmented it somehow, right? So I've broken up, I've taken apart the marks associated with implementation to include the dedicated category for the data set, right? So we're going to grade you based on the data set that you're going to compile, and then there's marks for the implementation, and then still there's a presentation, and then there's a report or something. And then also we are going to grade you. We are allocating about 2% to, I think this is project management really, but project management from perspective of what we're doing. So we're going to look at your notebook and see if the things that are in the notebook are going to make sense, right? If you structured it appropriately, for instance. And then of course we're going to check the commit messages in your repositories, with the one that you're going to share with us. So there's like two marks allocated to that. All right. With that being said, this is we're already behind time. Unless there are any questions, we can proceed, I guess. We can proceed with class, right? Now, a reminder that we're still looking at the CRISP DM methodology or approach. And we introduced it as something that is akin to what we do when we're developing software, right? We have these standardized or prescribed, not prescribed really, but recommended software process models. It turns out that when you're creating or when you're solving data mining problems, you find yourself creating what are called pipelines, right? So these pipelines would typically comprise of varying stages of a typical data mining project. So a stage related to data collection, for instance, a stage related to data understanding, data preparation, modeling, evaluation, and deployment. I guess something we can call implementation. And we've stated that there are a number of such methodologies, right? If you remember this paper, this classic paper, they actually, these guys do a really, really thorough job of trying to describe some of the most widely used data mining approaches or methodologies. And what we said was that we're going to focus our attention on the CRISP-DM model, which is what we're looking at. We're then going to gloss over schema, and then afterwards we'll again gloss over the KDD process, right? If you remember this this chart here, it turns out that most of these methodologies actually stem from the KDD process, which was proposed by Fayad et al. in the 90s, right? Anyway, so we did this, and we started going through the 6 stages or phases of the CRISP DM methodology. We started off with business understanding. Now here's the kicker, right? when what you're doing right now, your respective projects, when you're creating your pipeline, your notebooks, as you're working through a group-based project, what we expect you to do is to organize it based on either the CRISPM approach. So we expect to see sections that to speak to, oh, this is a business understanding, data understanding, all the way up to deployment. If that use schema, that's on you as well, right? But maybe we should alter it so that we just restrict it to one method. That way it will be a lot easier for us to grade you, okay? The other interesting thing here is, if you've been paying attention, right? Those of you that are smart and have already formed groups, you'd have realized that seeing as we've finished looking at business understanding, well, what's stopping you from conducting your business understanding linked to the topic you've chosen? Like if you're going to be building some classifier to do with the Jonas, the Journal of Natural and Applied Sciences from the University of Zambia, what you should already start doing is you start doing your business understanding. And how do you do this? Well, you poke around, you do a bit of research, and you realize that, oh, the journal Jonas is actually hosted on this platform, right, by the UNZA. So it's journals.unza.zm, and here it is, right? And I have access to all of these different issues, right? Because journals are periodicals. So I have access to all of these different issues. And you realize, as part of your business understanding, that in each issue, you will have articles, right? And you figure out that, oh, for me to harvest, for us, not me, because you're working with, I guess, 4 other people, for us to harvest information about Jonas, what we're going to have to do is we're going to have to extract information from each issue that has ever been published. And because these are periodicals, a volume represents a year, right? So meaning that you have 6 years from where to extract information. And Jonas, just like Jobs and JLSS, is a quarterly journal, meaning that they publish, in every year they publish 4 issues. And in each issue, what you're seeing here is where you're going to find the articles that you're interested in, where you're going to be extracting this information. So it will be like, oh, it's going to be 6 times 4. So meaning that we are going to, I don't know, this is you, right? It's not me. And I'm not saying that you're going to be doing this, whoever is going to be working on this problem here. But what you're saying is, oh, it's each volume, the number of volumes. This is your business understanding, part of your business understanding. There are 6 of them, okay? How about the issues? There are 4 in each in each year. How about the articles? Well, you realize that if you look at a typical issue, 1, 2, 3, 4, it's about 4 to, I would say 5 actually, a bit behind here. So let's say there are about 5 articles, meaning that the total number of issues are going to be 6 by 4, right? It's like 24 issues. The total number of articles, if each issue has an average of 5 articles, it will be 24 by 5. So you're going to be extracting whatever information you're extracting is going to be extracted from these 120 articles, and then you kind of build your data set or something like that. It's trivial stuff. But anyway, so my advice is you want to already start working on this, right? The sooner you start doing this, the better, actually. It's going to be a lot easier that way. So we've covered business understanding, and then we started our discussion of data understanding, where we realized that fundamentally, right, it's like we have phases have generic tasks have specialized tasks, and then you have your processes, right? Process instances, if you're paying attention here. So we realized that for data understanding, there are ideally 4 main generic tasks or general tasks that you perform, is it? There's identification of data sources, which we discussed at length. And I'm hoping that those of you that have formed groups have already started identifying the data sources. And then there's the initial data collection. Once you identify your data, we mentioned that what you do is you go out there and you harvest part of the information. And here's the thing: if you look at if you are working on the Jonas problem, you're looking at extracting 120 articles, right? Probably more, actually. Is you say, we're just going to extract information from one issue. Maybe it's issue number 6. I mean, volume 6, issue number 1, or maybe the most recent one. We're going to extract, our initial data is going to be collected from volume 6, issue number 2. Okay. So you do that, right? Instead of investing time heavily to extract data from all of the 24 issues. The problem with this is if there's something wrong with your scripts, for instance, you're going to have to redo that, right? So you do your initial data collection, and then and then the rest is history here. We explained what you do as part of data collection here. And then it turns out that after your initial data collection, one of the crucial things that you have got to do is you typically conduct what's called an exploratory data analysis exercise or activity. It's just usually referred to as EDA, right? So it's like your EDA process. And as part of the EDA process, here's the thing about the EDA process. You not only perform it during data understanding, but also during data preparation. And I think we mentioned this, right? But fundamentally, what we're saying is that you perform the initial exploratory data analysis as part of the second phase of the CRISP-DM methodology. And the idea is simple, really, right? What you're looking at doing in terms of exploratory data analysis here is you want to describe and explore the data that you have collected. Why? Well, you want to gain some sort of insight, right, on the information. If you're harvesting information from the UNZA institutional repository, for instance, DSpace, you don't know the structure you're working with here. If you're extracting information from the UNZA journal platform, you have no idea what this data is all about, right? So what you do is you collect the data, you obviously organize it in a certain way, and then you explore it, right? You start exploring, and what you discover when you start exploring data to do with the UNZA journal platform is, wait a minute here. An article, as it is rendered on the UNZA journal platform, has a whole slew of metadata elements. So sure, we are harvesting 120 articles, right? But each article has a title. Each article has author details. So it will have author first name, last name, their affiliation, right? Each article will have a digital object identifier, DOI, or each article has keywords, right? Each article has an abstract. And then you realize, whoa, wait a minute. Each article also has a bitstream, is it? The actual PDF document that has the content that people are interested in, right? So in essence, what I'm trying to highlight here is that many a times when you're actually working on a data mining project, you will have no idea, right, what the data is like, right? The structure of the data. What you do is you ideally explore it and you describe it, and your exploratory data analysis exercise is probably the easiest way of doing this, of exploring and describing your data. Some of the things that you see you do here in terms of describing and exploring the data is, for instance, you want to figure out the different attribute types, right? So if you have a data set that has a whole slew of attributes, right? Think of these attributes as columns, right? In our pandas data frame, actually, it's like a series. Each series will be of a specific data type. It could be categorical, for instance, where you have like a fixed set of values, male, female. That's categorical, right? Or more aptly put, actually, it's dichotomous because you have two values, at least in this part of the world. There's nothing like other here, or I don't know what binary, non-binary, and all that stuff that our quote unquote our friends in certain parts of the world have started, taking into account. So gender in Zambia is binary, is it? But it's a restricted set of values, male or female, or M or F or something. What else? You have other attributes, like it could be numeric or continuous attributes, and we'll discuss data attributes in the next lecture series here. You can also have textual content, right? And it turns out that one of the reasons why you would want to figure out the type of attributes you're dealing with is because as part of data preparation, when you're transforming this data, the techniques that you apply as part of the transformation process, like for instance, one hot encoding, for instance, would be they'll be aligned with the type of attribute that you're working with, right? So if you're working with categorical data, you'd transform your data attributes in a completely different manner than if you were working with a complete like textual content, for instance. Okay. And there I was wanting to I wanted to demonstrate something, but it's coming in the next lecture series anyway. I've noticed that when I context switch here, we end up wasting a bit of time here. But fundamentally, really, the purpose of your exploratory data analysis phase, or EDA, is to find or to gain insights from the data set, or insight from the source itself. Now here's the thing about insight, right? Insight could be things like the data from the Unza Journal platform is inadequate, or it's not comprehensive enough, or it's not complete, or it's not accurate, right? So you're using your EDA process to derive some preliminary insight from the data set so that you understand the data set. You know, I'm going to be the first one to tell you that what you will notice when you go to the Unza Journal platform, let's say Jonas in this particular case, you will notice is already a bit of a problem. Now we fix this issue, I guess. I should have used, we were fixing this event I was attending is tied to this project we are running. I don't know if I mentioned this, but it's an IFU, Workrane, and Agile funded project. You probably, maybe you might want to look at this actually. Those of you that are working on anything to do with journals, you probably do actually. You want to find time and go to our Diamond Open Access Publishing website. It's on the DRD thing here. Most of the problems that I've carved out are actually tied to this project. You won't read this. Also, I have two students that have scholarships. They're working on some of the problems that you're looking at. So, anyway, these guys here, Mwanga and Harris, but they're doing their PDIP, the postgraduate diploma in computer science. But anyway, so you are conducting like some preliminary analysis of the data and the source itself. Notice here, we're not saying it's just the data set, right? The data itself, but it's the data sources as well. I mentioned, if you remember, that many a times, right, you will find yourself with a sort of predicament where you have multiple sources from where you can extract the same type of information. So your EDA process will help you figure out the appropriate source of data to choose, if that makes sense. The student at risk of failing project, for the minor programs for the students, we have the option of getting that information from the preliminary survey that we always do at the beginning of class, or from SIS. After we did our EDA, we realized that extracting data from SIS was appropriate, right? Because the data there was more accurate, more comprehensive, right? More complete, in other words. And so it turns out that your EDA process also is instrumental in setting the stage for the data cleaning exercise that you conduct as part of data preparation. So you'll notice when we start looking at data preparation that we do a whole slew of things as part of preprocessing. Is it deduplication? Remove or stop words if you're dealing with text, for instance. Stemming, remove of punctuations, and all those things, right? Anyway, so it sets the stage for the data cleaning and transformation exercise that you conduct as part of data preparation. Now, in practice, what you tend to do is it's like you apply the EDA process as part of data understanding in the CRISP-TM methodology approach, right? And also as part of data preparation. Very important point here. So it's not something that you do just as part of data understanding here. Now, it turns out that there are various techniques that can be employed, right, to enable you conduct this EDA exercise. But fundamentally, irrespective of what sort of technique that you employ, typically it's visualizations. These are recommended. A recommended technique should employ visualizations, right? But fundamentally, what you're doing, if we were to put it out there explicitly, when you're conducting an EDA process, is you're trying to gain a comprehensive insight in the data set, identify important data characteristics, these attributes, right? So usually, as part of your EDA process, you realize to say, this particular attribute is not important for implementation of my inference model. So we're going to drop it or something. Or this particular attribute is not very important because it's correlated with another attribute. So because there's already an attribute that helps us, right, determine a relationship that exists amongst or between an independent variable and dependent variable, we drop it, right? To avoid a situation where you have this very large or vector, if you will, right? A dense vector. Right? The goal is always to come up with a sparse vector or something. But anyway, so you are identifying important data characteristics, but also identification of outliers. And here's the thing here: if I'm building an inference model, right, which is going to help me predict students at risk of failing, what you have noticed from the data I gave you guys is that I don't know if you've explored it. You better explore this because that's we're going to use that during the quiz, right? Next week, right there. You know, what you will notice is that there'll be certain observations, certain records that will be off. It's like exam score. In as much as the performance is overall, the performance is bad. Now, maybe talking about things in the abstract here, maybe be confusing for some people. So what we're going to do is let's see if we can if we can do this, right? I don't know if you remember this, but we realized that we can do a whole bunch of things. I'm going to import pandas as PD. And we say var student database is going to pd dot read CSV, and then the separator is going to be a pipe symbol here. I'm going to check the columns here, and then I'll pick a personal favorite is always the final exam. Wait a minute, let's look at the chaos as it relates to the very first test here. Horrible stuff here. So it's like let's see here. I don't know what I can do here, but maybe well, so it's like if I wanted to I can actually draw let me see if I can hist or something like that. You know, this is the thing here. When I'm using a terminal, it's horrible, right? matplotlib.pyplot, if you remember this, right? As plt or something, and then I'll have to do a plt dot show or something like that for me to show. I don't know. So if you look at this, right? I don't know if you can see the diagram here. It's a distribution of the scores, test one scores. Horrible performance, if you know, if you notice, right? I don't know. Maybe it's because it's very first test. But the idea behind this is you don't want to build this inference model by perhaps incorporating outliers. Outliers would be things that are off. They veer off from normal trend. Like you just have a few individuals that are just exceptional students, right? If you know what I mean, the gifted students or something, they walk amongst us like that. So what you do as part of EDA, you say we're gonna decide on how we're going to handle outliers. Maybe you exclude them, right, from the process you're following to build your inference model, for instance, right? So you're identifying outliers and anomalies. Anomalies are different from outliers. Anomalies in this particular case would be you have a grade that is 120. Well, we know that grades range from 0 to 100. So if we find something that is off from that range, it's an anomaly. Now, for this particular example, I mean, I don't really have a lot of kind of like anomalies, but imagine you are dealing with maybe financial transactions or something. So an anomaly would be like an account that has billions of kwachas or something like that, right? Anyway, so you're identifying as part of ED, identifying the outliers and anomalies, and then more importantly here, right? You want to determine any sort of correlations that exist amongst the attributes. Now remember, when you're deriving insight by, let's say, building predictive models, for instance, it turns out that you are building these models by dealing with two types of variables or attributes. Now you can think of these variables of attributes as but why this thing? I'm gonna close this here. It never works if I do Control C if I want to change it, right? It doesn't close. I don't know. I don't know if that's an applet also. But the thing is, when you're building your inference models, you're identifying variables, right? That you can, when altered, will influence the outcome of what you want to measure. So typically, an inference model is aimed at deriving a value that is measured, like a dependent variable. So you primarily work with two types of variables, an independent variable and a dependent variable. In this particular case, the obvious dependent variable here would be a final exam score. We want to maybe see what sort of grade a student is going to get at some point in the future. If we look at different combinations of these IVs, independent variables, accommodation status, gender, your workload, and all those things. So the idea is, behind the scenes, what you're doing is you're building an inference model that is similar to, and we'll talk about this, or maybe I don't know if it's Professor Mumbo or something, but you're building it in such a way that behind the scenes, it's like you're building, a nice thing about this is you're building an equation, right? The same equation that they taught us. I don't know where they taught you this, but the y is equal to mx plus c, right? The y is equal to mx. And in fact, this is what your typical inference model does, right? It's just creating this generic equation, which when fed different types of variables, it will tell you this thing that you want to predict, the y. Right? Now, what we are saying here is that as part of the EDA process, you want to see, are there any correlations that exist amongst the independent variables, but also, are there any correlations? It's like relationships, right? Is there a connection between something like gender? It's controversial, but I'm going to say it nonetheless, because these days females perform better than males, they've told us. It's like you're saying, is there a connection between gender and exam scores? Not that you're saying that gender, if somebody is male or female, then they're going to pass, there's a difference. It's like your classic causation, this has correlation, is it? It may not be gender actually that's causing the behavior that you're noticing, right? Could be other underlying factors. Like if you look at grade 12, girl child, right? There's more support being given to the girl child, which is why we're seeing a girl child performing far much better than the boy child, right? At grade 12. I don't know if you look at these scores here. So we're saying, even though we see a connection between gender, we see that Fs perform better than Ms. It's like the F is not the reason why, but there are other underlying factors. But that's not your concern when you're building an inference model, right? All you are mostly interested in is identifying relationships, connections. These are the things we're calling correlations, right? So you tell somebody there's a correlation, we see a correlation, a positive correlation between this variable and this variable. Like for instance, I'll be the first one to tell you that there is, I don't know about your group here, but for the first year computer systems and architecture course, there is a positive correlation between accessing Moodle and performance. It's like if you access, we see that for students that access Moodle more, in cases where students access Moodle more, on average, those students perform better, right? And it's not access to Moodle really, it's like engaging with the course. It's a marker that we're using to measure engagement. If that makes sense, correlation. We see that a lot more females perform better than males on average in the final exam. So we're establishing like connections that exist amongst the different attributes. Now, the thing here is that if you conduct this as part of your EDA process, it gives you an idea of how you're going to ultimately build this model, right? So you already have a sense of, oh, I'm going to build my predictive model, my classification model by experimenting with because I see correlations that exist between gender and final exam score, things like program minor and final exam score, workload and final exam score. What I'm going to do is, for these, for the set of attributes which are correlated with a final exam score, I'm going to experimentally determine to what extent they will enable me to build a more effective inference model. So it's like as part of your evaluation now, you're going to say, well, we've realized that workload is correlated with final exam score, gender, right? What else? It's like attendance or something, accommodation status. And then what you're doing, and we're going to discuss this, by the way, as part of evaluation, is you're saying, I'm going to build a model in such a way that I'm going to build a couple of different models here. The first model is just going to take in workload as the input, right? So it's going to be guessing, making this educated guess. The inference model is going to work in such a way that when you're training it with a lot of examples of workloads and final exam score. Say, if you see this sort of workload score, and this sort of exam, mark it or something, mark it, right? So that when you feed it new observations, things that it has not seen, it will be able to guess, right? Like next year, if I give it a student from CSC 4792 who has an engagement score of maybe, I don't know, it's like 7 out of 10 or something, it will tell me to say there's a likelihood that this person will fail or pass or something like that. Now there's something much bigger at play here, right? This is just one of many attributes that you can work with, like in this particular case. Maybe, not maybe actually, we'd want to also build a model that just takes in gender, right? So you're building it in such a way that it takes in gender as input, either M or F, and then you're training it. When you see this F, it's like this. This is what you're going to feed it. I guess it's gender and final exam score, like so. So you're going to say you're building it in such a way that you're giving it as input gender, and this is already labeled, right? This is going to be labeled as 54 is a pass, 9. Oh, somebody got 9% in the exam. 9 is a fail. So you have a lot of these observations that will have F in the input, F or M, and then in the final score, it's like pass or fail, pass or fail. And so you're building this model in such a way you're saying, if you see an F, if you see a lot of Fs that will fail or something, behind the scenes it will guess, right? It's like the way it works, it's a statistical model, really. Behind the scenes, it will be able to work in such a way that once you feed it new observations, it will give you a more or less like accurate guess, if you will, right? An educated guess, not accurate guess. A guess is not accurate. But the point I wanted to put across here is that you begin to notice that you can only decide or figure out whether you will build a model that takes in workload as input or gender or attendance or accommodation once you establish that there's some sort of correlation that exists. By the way, when you're building these models, what you do here is a whole range of things, right? It's like you're going to say, I'm going to build another model that takes in what? It takes in workload, and gender, right? I'll build one that takes in workload and see the performance, one that takes in gender, and then accommodation. And then I start combining these different things, right? Because maybe a model that takes in as input workload and gender will perform better than one that just uses gender, right? So you experimentally doing this. But anyway, the point I wanted to put across here is you determine correlations that exist, right? For the different data attributes or characteristics. Now, fundamentally, the outcome of your EDA process here is as follows. These are some of the things that will come out of the EDA process. You'll be able to determine which of the attributes are important. It's called feature importance, right? In this particular case, if we are building an inference model using this data set that helps us predict whether a student is going to pass or fail, we have the option of using as input student ID, student name, academic year, date of birth, year of study, school, status, sponsorship, government GRZ, 100% GRZ, 75%, 25%, and all that stuff. Category, motivation, workload, a whole range of features, right? Or attributes that we can use to build our model. But it turns out that some of these are useless. They're not going to help you in any way. In part because maybe they hold the same value, right? Or maybe the value itself is meaningless. Like it's unique to an individual, like student ID, for instance. Why would you want to use that as input when it's unique for each and every attribute? It's useless, right? So you perform as part of the EDA process, you will determine the important attributes. And then obviously one of the other outcomes is you determine the characteristics or attributes, right? Um, you understand the relationships that exist, the correlations, right? And then you'll be able to list any meaningful outliers, things that veer off from the norm or something. An outlier is not just linked to your dependent variable, the thing that you're measuring. I gave an example of exam score. An outlier can be date of birth, right? If you look at the date of birth here, if I extract the date of birth from here, what you notice is that I don't know if this is called date of birth here, but yeah, it is date of birth. What you notice is that there could be people that, fundament. I don't know if this is even a string also. Is it a string? It is a string. I don't know if it's a string here. But anyway, I wanted to see if I could find an outlier here. Oh, Christ. Damn it. If I can just say 1, 2, 0, 1, 2, 3. Nah. 0 to 3. 0 to 4. Look at this. If I just get, is it unique? I don't know. Unique. There's unique, right? You guys have been studying this. Unique. No, I guess it's a dot unique. There we go. Look at this, right? In as much as we have, I don't know if you've been paying attention to the things we've been doing here. Like if we try and count if we take the shape of this thing, right? It returns a tuple that tells us that we have 69 columns or 69 attributes and 273 observations in our data set. But for date of birth, right? In as much as we have entries for date of birth that are 273, we see that there are a set of unique, right, values. Now, here's the thing. I don't have to tell you this here. Okay. Is there something that you'd call an outlier here already? Can you tell? Maybe not. Maybe not. I don't know. But I don't know if you guys can tell that. Maybe you can't or something. Can you tell outliers here? You'd have to probably let me see here. This is a series, which is good. If this is a series, then what we can do is guys, I'm gonna do this the more retrogressive way here and create a new column called what have I done here? I'm gonna come back here and I did the wrong thing here. I'm gonna create a new a new column called year of birth, so that when I check the structure of this, it's going to have year of birth. Now, yeah, I could have done this the single line, but it could be a lot easier if I do this. Here's the thing here. If I get year of birth, but why? Year of birth like that. But it's double also. Year of birth, I did it twice. So we have year of birth like this, right? These are years of birth. If you remember what we said we could do is we could say group by, right? We could group by year of birth, is it? And then we can do a size or something. Year of birth. What I'm going to do is I'm going to run this on year of birth like this. So here's the thing. You may not know right away that there are certain outliers, but you can check here, right? We have outliers on either end of the spectrum. There are some people that were born in 1983 here that were enrolled into this program, right? But what we see here is that In fact, you could say these are outliers, right? People that were born maybe before 1990 or before 1991 or before 1992 are outliers. And then there's also this outlier here, right? It's like somebody was this is a person who probably skipped a grade or something. But this, uh, you know, I wonder who this is here. But as in, I wonder. I'm just curious, right? If you remember that thing, how do we check? We could check if year, if you remember, year of birth is equal to 2004, 2004 something. I don't know if this is int or something like that, but anyway, I wanted to showcase. I wanted us to look at this particular case here, where the year of birth is equal to 2004. I'm looking at the time here, so that you could see the year of study. The last time I refreshed this thing was 2023, I believe. So if somebody was born in 2004, when they were in first year enrolled into this course in 2023, they were and I think this is a bit of, they were like 19 or something. For this course, I don't know. Oh, this could have been, I think this person could have been in previous years or something like that. Anyways, the point I'm trying to put across here is that here I'm identifying outliers, right? Because we have this data set that has 273 observations, but you have these peculiar cases, right, where you just have one instance. The idea behind an outlier is if you include this in your model implementation process, it's not going to help you in any way, unless if you decide to generate synthetic data, right? Which again is still going to lead you, it's going to result in a lot of problems, right? So you would identify a list of outliers, and outliers can be tied to the dependent variable and the independent variables also. Outliers as they relate to program miners. Maybe it's just one person who is decided to mine in that program, for instance. Outliers as they relate to things like, I'm trying to see here if I can give other examples of outliers here. Nationality, right? You have somebody who is a refugee, who has a refugee status, something like that. Anyways, so that's the outcome here. Now, the thing about, because you are supposed to do this in your respective projects, as you're working through, and we expect to see this in the report and the notebooks, when you start undertaking your EDA process, it's usually a lot easier when you get started if you ask leading questions. For instance, a leading question like, what are the different types of data attributes? Asking this question will force you to check the attributes associated with all of these 69 data attributes. What is the data attribute for year of birth? They're not 69, by the way, anymore. They are now 70, right? I've created an additional one, this year of birth, right? So you're asking leading questions. Other leading, and we discuss the different types of attributes, right? The things that they taught you in your statistics. When they're saying for you to decide on whether you're going to conduct a chi-square test or an over test and stuff, you have to look at the attribute also. Is it an ordinal, right? Like the values are discrete like that? Is it continuous? Is it numeric? Is it categorical? Is it dichotomous? And all those things. But other leading questions that you ask is, how is the data distributed? Is it, does it form a bell curve? Is the data normally distributed, right? Where you have results clustered like at the midpoint or something? Or is it non-normally distributed? Is there a correlation, or are there correlations amongst data attributes and the outcome? Is there a correlation between sponsor and final result? Now, do you see a situation where those that are on 100% sponsorship perform better than those on 75? This is what we're saying. This is like a positive correlation. In some instances, it will be a negative correlation, right? What are the most important attributes? Remember we mentioned feature importance, right? So this question will lead you down the path where you say, oh, out of all of these 70 attributes, we see that the most important ones would be things like campus accommodation, workload, Moodle hits, right? Feature importance. Other questions would be, what must be done to data attributes with missing values. So this thing of handling missing values is normally done during pre-processing, but when you conduct your EDA process, you can then decide on how you're going to handle such values. So the idea behind missing values is simple, right? If I look at scores here for final examination, guess what? But why? Guess what? This thing, this thing called final exam has these entries called NA, not a number. These are now entries. So there are some students that probably didn't write the exam, or they're missing scores and stuff. You have to ask yourself the question: how am I going to handle observations that have no exam scores? Now, for some problems that you'll be working on, it's simple, right? Like for predicting student at risk of failing. If there's no exam score, then you exclude that observation. You don't want to include it in the process of building the inference model. You say, I'm going to, first of all, I'm going to filter this data frame in such a way that I exclude anything that does not have exam scores, right? You're answering this question here. But you discover, we'll discuss this as part of data preparation, I think it is, or processing. So, some other decisions you can make, and which is tomorrow, I think, is we are going to add default values. If a person does not have an exam score, it's a 0. We're just going to say it's a 0. Now I know, like, but what if this person, just did not write the exam? Why would you say it's a 0? It's a decision you have got to make. And usually this decision is informed by the outcome of the very first phase, which is business understanding. In some instances, believe it or not, the way you handle now values is, I'm just going to get an average score. It's just going to be an average score. If the value is missing, I'll look at the average, the mean, the arithmetic mean from all the observations when I remove outliers, and then I'm going to use that as a way of filling in the blanks or something like that. But also, the other question you ask is, does the data set, or do the data sets have outliers? Right? So a couple of leading questions that you ask. Now, the thing here is that the recommendation is you take an approach which heavily makes use of graphics, and hence the reason why we had a discussion of matplotlib here, right? So an easier way of trying to determine outliers that exist is using graphs, plots, charts, right? So you're graphing the data, especially in instances where you have no domain expertise in terms of the data you're working with, right? So you heavily rely on specific types of attributes, and it turns out that the type of visualization graph that you use is dependent on the attribute. If I have a dichotomous attributes, male or female, why would I want to generate a histogram? Histogram shows you distribution of scores. What do? Well, what I'm going to do is I'm going to use a pie chart or a bar plot, right? A stack bar plot or something like that. Anyway, and then finally, right, remember we are looking at 4 general tasks, and then each general task has specialized tasks, and you have process instances, right? The final general task as it relates to data understanding phase, right? If you've been paying attention, I don't know if you've been paying attention here. Christian model has phases. Each phase has generic tasks. Each of the generic tasks is associated with specialized tasks, and then you have process instances. So what we're saying is the general or generic task, the other generic task associated with data understanding is data quality assessment. And what you're doing here is using the initial data. Remember, you have initial data collection here. You want to determine whether the quality of data that you've harvested, that you're going to get from the data source, is good enough for you to implement this inference model. So it's just a quality assessment. And as luck would have it, a nice way of determining the quality of data is you rely on the EDA process. So it feeds into this. It's like how many now values do we have, right? Those sort of questions. How many missing values do we have, right? It's quality assessment. So what you're doing to ascertain the quality of the data here is you're checking data integrity here. You're evaluating data for its completeness. Are all the attributes, do they have values, right? Is it accurate? Believe it or not, some data will not be accurate, right? You extract data from a database and they tell you the exam scores are wrong. You should have picked these exam scores from the actual lecture or something. Okay, right? Um, and then this issue of identification and assessment of the impact of missing values, right? So if you do exclude missing values, if you decide to use arithmetic mean or median values as a replacement for what is missing, what are the implications of doing that? Listen, I'm hoping here that this is all making sense. And then in terms of the outliers and any sort of noise that may exist here, you're identifying things that may distort the results, the data that you've harvested, right? And then more importantly, during the assessment of the quality of the data, what you're doing is you are planning for the next phase here. You're coming up with a series of steps you're going to follow for you to process the data, for you to clean the data prior to analysis. So in other words, in terms of the data understanding phase, really, that's it. Pretty trivial stuff. My advice to your respective groups is, by now you should already come up with a plan, the groups you formed, for how you're going to work towards these generic tasks. Is it identification of data sources, initial data collection? You should already start planning, putting together a script in your Jupyter notebook that's going to show us or show you or enable you to conduct your exploratory data analysis. And then you do your initial, or rather you do your data quality assessment, right? To determine if you're working with the the Jonas journal, you want to do a quality assessment to figure out if the quality of data from the Jonas journal platform is good enough. Here is me telling you it's good enough. I know, right? Are there any questions about this? When we meet tomorrow, we have class tomorrow. Tomorrow is Tuesday, right? We have class. Um, a reminder that the Tuesday class, because the people from Mines here, they're saying the venue, we can't use that venue here. So our class on Tuesday, this is FYI to those people that keep saying, I wish there was a very, a detailed plan on how these lectures are conducted. This is there. See, there's a there's like a calendar that's been shared. Right? We know that on Tuesdays we meet at 17. So I'll see you at 17, ladies and gentlemen. Unless if Ms. Ebenezer and Ms. Mlela and Mr. Chela here have spoken to the head of department so that we find a venue. In an ideal case, I would really love it if especially the Tuesday slot, similar to the Thursday slot, was in person. But Thursday has got to be in person because this is when we're going to be doing our quizzes here. If there are no questions, ladies and gentlemen, please prepare for the in-class quiz, which is stroke lab next week. If you have not yet formed your group, deadline is tomorrow. Please form that group. If you have not yet started doing this, you must start preparing for the test, which we are writing. We are writing in the last week of classes. So we have 1, 2, 3, 4. We have 5 more weeks before the test. And if you have not started doing this as a group, nobody is going to, at fourth year, I'm going to tell you to say you must come up with a plan where you are meeting at least once a week to discuss the project, right? Project management 101. You want to come up with a rigid plan where you're meeting regularly so that you make progress in this. If you think you can game this, right, it's going to be really hard for you. I've tried as much as possible. I've tried to make sure that it's going to be incredibly hard for you to even use these large language models, right, to find solutions. But I know some of you are very persistent here. You'll be cheating like that, but that's okay also. We shall find you in the presentations. Mr. Boss, yes, is it? Yes. There's a question. There's a hand up. I thought there was a hand up from Boas, but no, nothing yet. There's a. I mean, honestly, sir, personally, I'm finding it difficult to follow what. Ooh, now, Sipiso, tell you what. Why don't you find time? Come and see me on Wednesday. I mean, 515, right? Come and see me, and then we can have a chat about this. Uh, I've been trying to give context and to rub it in, but also what you want to do is I make available recorded screencasts. I'm recording this session. I'm going to make it available. You can play it back at your own time. But Sepiso, come and see me. I'm happy that you're honest enough to tell me that you're not following through here. At this stage, I'm expecting most of you to follow through what's happening. Just to be clear, if we choose a specific journal, let's say natural blah blah blah, do we have to choose one specific? Well, so this question is going to be answered when we look at model implementation, because it turns out that when you're building inference models, and I'm going to showcase this to you, seeing as you've asked this question, it's one of question. When you're building inference models, there's usually, let me just say, I like using the scikit-learn map or something. There's generally kind of like a minimum. You typically would need a reasonable number of observations to build your inference model. So the scikit-learn website has this really nice. I don't know, it's not coming up here, but they have this really nice. There we go. They have this really nice diagram here. I don't know if you can see this. But what this is showcasing to you is, you say when you're building an inference model, right, for instance, right? We start here. You first of all do what? You ask yourself a question. Not that this is all the time, right? But how many observations do you have? The number of samples, 50. I mean, are they less than 50? If no, go and get more data. Are they greater than 50? If yes, right? What sort of inference model are you building? So generally, to answer your question, even though we're going to this, but data from one issue is not going to be enough, because one issue for Jonas only has 5 articles. So no, that's insufficient. But it's sufficient for you to do your EDA, right? Your initial data collection, so that you perfect your scripts, the scripts that you're going to be using to harvest this information. My other advice to you is, most of these data that I'm asking you to go and pick, this data is there are APIs, like for instance, Jonas data from the Unza Journal so the Unza Journal platform runs OJS, but you know this, you can go to Beltwith, is it beltwith.com or something, and you can look up what sort of tools are being used to power whatever platform you're looking at. But also, if you look at your developer tools, what you notice is that this thing is, I want to come here. If you look at the head tag, this thing, now you see now, this is why you should be learning, you should know how to use HTML. If you are just relying on tools to automatically generate this information, you'll be lost here. Like, what's happening here? But that's on you. If you look at this, you notice that this thing runs a version of a content management system called OJS. Now, what you discover if you do your due diligence as part of this business understanding, and you study OJS, you realize that, oh, well, OJS it's implemented. It has it has the Open Archives Initiative protocol for metadata harvesting activated. If that's the case, the OIPMH protocol has different verbs, and we can use the list records, right? Verb for us to harvest not the actual bit streams really, but at least the metadata. You understand? If you're working on, let's say, the social repository, DSpace, if you've chosen that, well, Unza uses DSpace. Well, DSpace is a free open source repository, and this free and open source repository also has the OIPMH protocol activated. Right? So if it does, then we can automatically extract information from there. What else? You say if you're working on the government gazette thing, you say, oh, we found that there's information on parliament.gov.zm, but also on zambialai.org. And if you go on zambialai.org, we'll find all the government gazettes. They're right there. Now, I don't know what sort of platform Zambialai uses, but all the gazettes are here. So we know where to harvest information. They're organized by year. I don't know if you remember the Government Gazette. They taught us in civics, myself in grade 8. I don't know if it's grade 9. The Government Gazette is, now it's coming here. So you have to figure out how to harvest this information, right? I'm going to download the Government Gazette like this. I don't know if you guys even know about the Government Gazette, right? It looks like this. This is like official communication from government. There's a wealth of information here. People, if you ever want to change your name, you appear here. You know that? If you want to change your name, those of you want to change I've decided to change my name here. I don't know. In some instances, for people that have died and you want to reach out to any creditors and debtors or something, you do this, right? Notice to creditors and stuff. You're gonna have fun. Those of you that are working on the Government Gazette. By the way, my advice to you is, even if you're working on a project that has nothing to do with the Government Gazette or Parliament, what you probably want to do is just poke around the other datasets and just see if there's anything exciting there. All right, ladies and gentlemen, this is 1909. We still have class tomorrow. I'll let you think about what we discussed, phase number 2 of the CRISP-TM model. And then, no, so Monica Shaw is saying the syllabus changed. No, what are you talking about? What? No. What syllabus has changed? No, the syllabus has not changed. This is what we are looking at here. This is the same syllabus here. Why would I change the syllabus? I'm told what to do here, right? They tell me they give me instructions, do this, and I do it. Go and teach this, I teach this. We're looking at this, right? Very, very soon afterwards, we're going to start looking at this. So no, some things we are probably going to combine. They'll come from different these different categories here. But thank you very much. The syllabus has not changed, Miss Shower. Oh, civics. Oh, she meant civics. No, but still, you're lying, Miss Shower. Civics, they don't teach the Government Gazette. He taught me. There's this gentleman who was quite old. I don't know if he's still alive. He taught me civics, right? In grade 8, and they were teaching us about the Government Gazette then. It's like, there was that rote learning where they're forcing you to commit to memory. What is the Government Gazette? The Government Gazette is official, whatever. Guys, good night. See you tomorrow.